Somewhere in a factory in China right now, workers are bolting battery packs into a small electric car that does not contain a single gram of lithium, not a reduced amount, not a cheaper blend, none. For more than 3 decades, lithium has been treated as the one ingredient every electric vehicle simply had to have, the rare, expensive, geopolitically messy material that every battery maker on Earth had to fight over. China just built a mass-produced passenger car that skips it entirely, and the battery inside that car is already rolling off assembly lines by the thousands. When people in the battery industry, including engineers who have spent their entire careers working with lithium, saw the specifications on this new pack, the reaction was not skepticism. It was closer to alarm. In this video, we are going to walk through exactly what this new battery is, why sodium was considered a joke replacement for lithium just a few years ago, why that joke stopped being funny almost overnight, and why companies and policymakers in the United States are now scrambling to respond to a technology shift they did not see coming this fast. None of what follows is speculation. This battery is already in a real car, on real roads right now. Let's start with the company at the center of this story, because it is not some small startup nobody has heard of. It is CATL, the largest battery manufacturer on the planet, the same company that already supplies cells to a huge share of the world's electric vehicles. From budget compacts to luxury brands you would recognize instantly. CATL calls its new sodium-ion battery platform Naxtra, and earlier this year the company confirmed it has resolved the core manufacturing challenges that had kept sodium batteries stuck in pilot programs for years. That announcement came directly from CATL's chief scientist, an academician in the Chinese Academy of Engineering, who stated plainly that the company was ready to move sodium batteries into large-scale production. This was not a lab demonstration meant to generate headlines. It was a company with the largest manufacturing footprint in the battery industry, saying in plain language that the technical bottleneck was solved. The first real-world proof of that claim already exists. A Chinese automaker called Changan, working directly with CATL, has begun producing what is being described as the world's first mass-produced passenger electric vehicle powered by sodium-ion battery cells, known in some markets as the Nevo A06 and elsewhere as the Changan A06. This is not a prototype sitting on a stage under studio lighting. It is a real production vehicle, expected to reach customers by the middle of this year, built on a real assembly line, using a battery chemistry that industry analysts spent the last decade assuming would never make it out of stationary storage applications, let alone into a car you could actually buy and drive to work. So why does removing lithium matter so much? To understand that, you need to understand what lithium actually costs the world beyond the price tag on a battery. Lithium has to be extracted either from underground brine reservoirs in places like Chile and Argentina, or mined from hard rock deposits, most heavily in Australia. Either way, the supply chain is narrow, concentrated in a handful of countries, and heavily processed and refined through Chinese industrial capacity before it ever becomes a usable battery component. China alone controls something like 70% of global refined lithium output and roughly 90% of the world's cathode material processing, meaning that even lithium mined thousands of miles from Chinese soil usually still passes through a Chinese refinery before it ends up inside a finished battery cell. Sodium does not have that problem. It is one of the most abundant elements on the entire planet, roughly 1,000 times more common than lithium, and it can be extracted from ordinary sources like salt and soda ash almost anywhere in the world. That single difference changes the entire economics of building a battery. Early estimates put sodium-ion cells at roughly 30% cheaper than the current standard lithium iron phosphate chemistry that dominates affordable electric vehicles today. And that gap is expected to widen further as manufacturing scales up and supply chains mature. There is a second advantage that matters just as much to regular drivers, and it has nothing to do with price. Sodium-ion batteries handle cold weather dramatically better than lithium-ion cells. According to CATL, its sodium-ion packs can retain more than 90% of their rated capacity at negative 40 degrees Celsius, a temperature that would cripple the range of most conventional electric vehicles on the road today. Anyone who has owned an electric car through a genuinely cold winter knows this problem intimately, watching the estimated range on the dashboard drop by a third or more the moment the temperature falls below freezing. For drivers in northern China, Scandinavia, Canada, or the northern United States, that single improvement could matter more day to day than almost any other spec on the vehicle. Changan has stated that its sodium-powered Nevo A06 retains roughly 3 times more usable capacity than a comparable lithium iron phosphate battery when temperatures drop to negative 30 degrees Celsius, a claim that, if it holds up in independent testing, would represent one of the more meaningful quality of life upgrades electric vehicles have seen in years. There's a quieter part of this story that rarely makes headlines, but explains why the cost curve is falling as fast as it is. Chinese material suppliers, working alongside CATL, have been cutting the cost of the specific components sodium batteries depend on, things like polyanion, cathode material, and hard carbon anodes, in some cases reducing processing costs by 30 to 50% within a single year. One major cathode material supplier has already brought those costs down significantly, while a separate chemical manufacturer has been shifting away from imported coconut shell-based anode material toward domestically produced alternatives, a change expected to cut anode costs by more than 40% over the next couple of years. None of that sounds dramatic on its own, but stacked together, it is exactly how a battery chemistry goes from a laboratory curiosity to a genuinely cheaper mass-market product in the span of only a few years. This is the unglamorous, spreadsheet-level work that actually decides who wins a materials race. And right now, it is happening almost entirely inside Chinese supply chains. Now, sodium batteries are not a perfect replacement for lithium, and it would be dishonest to pretend otherwise. The current trade-off is energy density, meaning a sodium battery pack of a given size and weight simply cannot store as much energy as an equivalent lithium pack today. Early sodium cells are landing somewhere around 150 to 170, 5 watt-hours per kilogram, noticeably below what modern lithium iron phosphate batteries achieve. In practical terms, that means a sodium-powered vehicle today typically delivers somewhere around 250 to 350 kilometers of range, solidly enough for city driving, commuting, and most delivery fleet applications, but not yet competitive with the 300 to 600 kilometer range that higher-end lithium-powered vehicles routinely offer. CATL itself has said that once its sodium supply chain fully matures, it expects the technology to eventually support vehicles with up to 600 kilometers of range. But that milestone is still ahead of us, not behind us. In other words, this is not a battery designed to replace every lithium-powered vehicle on the market overnight. It is a battery designed to dominate a specific, enormous slice of the market first: the affordable compact car segment, commercial delivery vehicles, city buses, and stationary energy storage, before eventually climbing into higher performance territory as the chemistry improves. And that specific slice of the market happens to be enormous. CATL has said it expects somewhere between 10,000 and 20,000 vehicles to ship with its sodium-ion packs before the end of this year alone, a modest number compared to the overall EV market, but a genuinely significant milestone for a battery chemistry that most of the industry assumed was still years away from any real commercial deployment. And CATL is far from the only major Chinese player moving in this direction. BYD, the company that recently overtook Tesla as the largest electric vehicle manufacturer in the world, broke ground on its own dedicated sodium-ion battery facility in Chuzhou back in early 2024, a plant with a planned annual capacity of 30 gigawatt hours, representing an investment of roughly $1.4 billion. That facility is aimed specifically at powering compact vehicles, scooters, two-wheelers, and small city cars, exactly the segment where sodium's current limitations matter the least and its cost advantages matter the most. A third company, a smaller Chinese battery maker called Hina, was actually the very first in the world to put a sodium-ion battery into a commercially available electric vehicle, doing so back in 2023, years before either CATL or BYD brought their versions to market. When you have the largest battery company on Earth, the largest EV manufacturer on Earth, and an earlier pioneer all racing toward the same chemistry within a few years of each other, that is not a coincidence. That is an industry making a coordinated bet that sodium is about to become a serious part of the mainstream battery mix, not a niche experiment. Here is where the story stops being purely about batteries and starts being about global power. China currently manufactures somewhere around 80% of the entire world's lithium-ion battery cells and controls a similarly dominant share of the global lithium refining and cathode material supply chain. That level of control has made policymakers in the United States and Europe increasingly nervous for years, not just because of cost, but because of what happens if that supply gets restricted or weaponized during a moment of political tension. China has already demonstrated a willingness to use its dominance over other critical materials, including rare earth elements, as leverage in trade disputes. A battery supply chain that concentrated in one country's hands is, by definition, a national security vulnerability for everyone else. The United States has even passed legislation requiring the Department of Defense to eliminate Chinese-sourced battery materials from its supply chain by October of 2027, a deadline that is now creeping uncomfortably close given how far behind domestic alternatives currently are. Sodium was supposed to be part of the answer to that problem, not another extension of it. Because sodium's raw materials are so widely distributed around the planet, The theory was that countries like the United States, which has some of the largest known reserves of soda ash on Earth, could build an entirely independent sodium battery supply chain, free from Chinese material control for the first time in decades. That is exactly the argument being made right now by a newly formed American industry group called the American Battery Leadership Coalition, made up of sodium-focused startups working to establish domestic manufacturing before Chinese sodium technology becomes as dominant as Chinese lithium technology already is. Their concern is blunt and specific. China is not just ahead in lithium, it has now moved just as aggressively into what was supposed to be the alternative chemistry, backed by companies with existing gigafactory-scale manufacturing experience, deep government support, and years of head start in actual production knowledge. Several American analysts have said versions of the same uncomfortable sentence recently, that if sodium ever becomes cheaper than lithium at true global scale, it will likely be Chinese companies who get there first, for exactly the same reasons they got there first with lithium. That is precisely why the announcement out of China landed as hard as it did in American industry circles. This was not supposed to be how the story went. Sodium was the technology the rest of the world was counting on to finally escape Chinese battery dependence, and instead, China simply took the lead position in that race as well, years ahead of schedule, with a mass-produced passenger vehicle already built around it, while American sodium companies are still mostly working through pilot projects and early-stage storage deployments measured in single-digit gigawatt hours, rather than tens of gigawatt hours. American sodium startups do have real advantages worth mentioning, honestly. Companies like Peak Energy,